Hello and welcome to the question. This is Matthew and we are going to be doing question 13, which is a 15-mark question. So we are showing the graphs of 5 different quadratic functions labelled a, b, c, d and e, and we have to match them up with the correct functions. So now let's have a look at our functions. So we have fx is equal to x squared, gx is equal to x squared minus 3, hx is equal to minus x squared plus 3, px is equal to x minus 2 squared, and kx is equal to minus x minus 2 squared plus 3. So we're going to start with fx is equal to x squared. So now let's go up and have a look at our functions. So x squared, so we know any number squared is always going to be positive, so therefore we have to have an equation that does not have any negative numbers in it. We also know that x squared, we can tell that a point on that will be 0, as 0 squared is 0. So therefore we can tell that it is c. So fx is c, as I said, because we know that there is no negative y values, or no negative outputs I should say. And as well as that, 0, 0 is on the graph fx, so that means that fx must be c. Okay, so now our next graph is gx, so x squared minus 3, so let's go up and have a look. So x squared minus 3, so that's going to mean that we'll have the graph similar to fx, but it will be moved down 3. So we can tell that that must be graph b, as it's the only graph that looks similar to f of x, and it is moved down a bit, which must be the minus 3. So therefore we can say that the graph g of x is b, as we have x squared drops down 3. Okay, so our next function is h of x, which is equal to minus x squared plus 3. So the minus x squared is going to invert f of x, and then plus 3 will rise it up 3. So now let's have a look. So we're looking for a graph that is x squared inverted, so basically x squared upside down, and also that has risen by 3. So the only two graphs we have that are x squared inverted are a and e. However, a has moved slightly to the right, whereas the graph we're looking for is still going to be in the center, but just risen by 3. And we can tell that e has risen by 3, so therefore h of x must be e. So now we have the graph p of x, which is x minus 2 squared. So we're going to have a look up at the graphs now and see which one will match that. So we are looking for the graph of a function that is like x squared, but that has moved to the right 2 steps. We can also tell that a point on this function will be 2, 0, as if you put in 2 for x, you'll get 0. So we can tell that D suits both of these points, as we can tell that 2, 0 is on D, and we can also tell that it is like x squared, however it has moved to the right, and that must be to the right 2 steps. So therefore we can say that p of x is equal to D, as x squared moves to the right by 2, and 2, 0 is also on the function. So now our final function is k of x, which is equal to minus x minus 2 squared plus 3. Now it's important, we can't just say that k of x is a, as it's the only function left. We do actually have to give a proper reason. So now let's go up and have a look. So we know that it will be similar to x squared, however it will be inverted as it's minus. It will also move to the right 2 steps, and it will be lifted by 3 as it's plus 3. So a suits all of these points, so therefore we can also say that k of x is equal to a. So there we have it, all of our labels and all of our reasons filled in, and that is our answer for question 13. Thank you very much for watching, and I hope I helped.